So the title page or the title of this topic session is called Japanese Influence on Global Supply Chain Technology, with the subtitle From Lean to Artificial Intelligence. So before I get started, I might just ask very quickly, if maybe by a show of hands, I don't think I still have access to this now that I'm on a full screen, but how many of you are familiar or have any familiarity with lean manufacturing or lean distribution or anything having to do with lean? And I kind of set my screen down in a smaller view so that I can actually just quickly check the chat to see the responses. Are you familiar at all with what lean is? You might have heard the term lean manufacturing, or in some cases, something called Six Sigma. Okay, I'm getting some no's. I'm getting one yes. So I think this might be a really interesting hour. In other words, this will give you some real, maybe some introductory exposure to the field of lean manufacturing and lean distribution, and how important Japan has been in that, and where we can go from here. So one person, lots of auto manufacturing. Yeah, familiar with lean. Great. So let me share again, and we'll see where to go from here. Just one second. Now, while I'm in full screen, I'm not going to be able to see the chat anymore. So I hope that Yumi and you might advise me if there's some important comments coming through. Okay.
Yes.
So skipping forward a little bit, just to clarify a little bit what Yumi said. So I teach operations management. I also teach supply chain management, and I teach a course called Supply Chain Decarbonization at the University of Pennsylvania. So these are three different cuts on what is operations management, what is supply chain management, and looking to the future. The decarbonization part of it is how to achieve a low carbon or zero carbon. Some of you may have heard the term net zero, how to achieve energy efficiency and low carbon energy usage within the entire supply chain. So those are my topics, and within each I've listed down the class sessions. This is what I do with part of my life. I talk about and I explore and I research these aspects of things with my students. I'm also peer advisor, a capstone thesis advisor to a lot of students, and on these topics. So some of you may find some of these books of interest. That's why I put some of the titles here. These are, Yumi mentioned two of them. She mentioned The Guide to Supply Chain Management up here for The Economist, and she mentioned Reinventing the Energy Value Chain here. These are some of the topics that I write about and think about and talk about. There were a few political ones and more mainstream ones related to trade, such as this one, Trump Trade and the End of Globalization. This one called Getting to Net Zero, and this one called From Bogota to Beijing. Some of them are, if you're looking for beach reading, I would suggest From Bogota to Beijing. If you're looking for really clear and succinct text on what the heck is supply chain management, I'd say this one, and then I can guide you with other ones if you're interested. What I do when I'm not teaching is I run a consulting firm called Boston Strategies International, and we do supply chain management, mostly in the energy industry, and here are some of our clients. So we serve with these big international clients. A lot of it is in oil and gas and power, big infrastructure projects. It's kind of the stuff that we work on related to supply chain management. And I have also worked a lot, it's not on here, but I also worked a lot in the auto industry. So for Ford and General Motors and Fiat and Renault and around the world. Germany, Brazil, the United States, France, a lot of different places. So moving into the topic du jour. So speaking of France, it's a topic du jour. So first we're going to talk about Japanese thought leadership and supply chain management theory. There is a lot of it, and it's very exciting. And then we're going to talk about Japan's experience with supply chain resilience through the shocks that it actually suffered, particularly as a result of the earthquake and tsunami. And I just lost the screen. Hang on a second. How do I get it back? I don't know how to get it back. There was an alert on my here as an alert. All right, that interrupted all right. And third, we're going to talk about Japan and digital supply chain management. Where is digital supply chain management going to go, and how does Japan fit into that picture, which is really interesting as well, because Japan can play a really big role in the future of supply chain management. And then we're going to talk about what lies ahead. So in the area of Japan's leadership in supply chain management and theory, we're going to cover some total quality management, which some of you may also have heard about. Those who are familiar with Lean might have heard about total quality management, or TQM. We're also going to talk a little bit about the Toyota production system, or as it is known in supply chain management, TPS. Everybody, when you say TPS in some circles, it's really well understood. There have been volumes and volumes and volumes of books written about the Toyota production system because it is so unique and so informative. And then we're going to introduce some concepts called time to respond and time to survive. These are ways to measure supply chain risk and resilience. We all found out about the need to deal with supply shortages in the pandemic. And so we're going to talk about how to measure and manage that, and also using Japanese examples. And when we talk about digital supply chain management, that's going to cover three areas: electrification, automation, and artificial intelligence. And I think that will it just went the wrong way. Sorry. There we go. And when we talk about challenges and opportunities, we're going to explore productivity, jobs, and education, and how artificial intelligence is going to change all those. So it's a lot of big topics, and I think it's kind of be interesting for you. But starting with Japanese thought leadership and supply chain management theory, there were a number of Japanese, what we call quality theorists, who made a big impact on manufacturing in around the world. Post World War II, really extraordinary contributions by a number of engineers and management scientists in Japan. I'm going to talk about a few of them. One of them I'm not going to talk about, it's not on the slides, but I'll mention, were several Americans who went to Japan and spent a lot of time working with Japanese companies, including Toyota. One of them was named Deming, W. Edwards Deming. Mr. Deming introduced a lot of he helped pioneer a lot of Japanese management concepts, and then introduced them to Western companies, for which afterwards there was a Deming Prize instituted, and it's a government, U.S. government sponsored prize that's I don't know if it's still awarded, but it was for decades. So it really became part of the management culture in the United States. Another one was Mr. Schuhart, who pioneered statistical process control. So there were a number of Americans involved in working with these folks who were Japanese, but I thought I would mention the Japanese ones, particularly since the production systems that came out of them were really transformational for manufacturing across the globe. So Kora Ishikawa was one of the quality gurus, and he really worked with the concepts and it pioneered the concepts of continuous improvement, zero defects, quality circles, worker involvement, and quality diagnostic tools. The important aspect of what he brought to the field of operations and supply chain management was people-centered quality. The notion that you can't really achieve a quality process or product unless the people are engaged and everybody is engaged. And when you further talk about a goal of zero defects, the only way that you can get zero defects in a fairly complex organization is if every single person in the entire organization is aligned on the quality goals and is empowered to achieve those goals. So those are really big challenges, especially coming from where manufacturing was in 1950 and 60, which was a hierarchical, very sort of military paradigm activity, to actually empower workers to make decisions without being told what to do, and even to make contrary decisions when they were told one thing to do another, because it was better for quality. This was huge. It was a big mindset shift. And the second thing I want to highlight on here is the notion of continuous improvement. The notion that you could establish a quality target, but the goal is not really just the target. The goal is that the target keeps moving every single day a little bit better. And this is also involves a very big mindset shift. It means that every day you walk in, the target is not what it was yesterday. Everybody needs to be driven to perfection. And so in order to enable this, you really need to have what they called quality circles. And quality circles were pretty much daily meetings that involved a cross-functional team of people from different departments who came together to troubleshoot and discuss the issues and the problems that were being experienced and how they could solve them together. And what they discovered was that, even though they originated in one department, the person who could resolve them might sit in a different department, and you needed to have those people together in a circle to talk about it. So the other aspect of this, which I'll get into more in a few minutes, is a set of quality tools which are used widely today, such as scatter plot diagrams, checklists, and Pareto charts and a bunch of other charts, which I'll explain. But these are kind of simple. If you've ever heard of the 80-20 rule, for example, the 80-20 rule was invented by an Italian economist named Pareto. It's called the Pareto principle. But the use of quality tools such as the Pareto chart and such as histograms and such as statistics to measure quality defects originated back in this period here, and it became part of the people-centered quality. So the people who were sitting in these quality circles were sometimes looking at and discussing very simple quality defect issues, and sometimes they're looking at data. They're looking at data on quality. So that also brought a little bit of a cultural shift, because a lot of the people who needed to sit in these quality circles were not trained or educated really as managers, right? But we were bringing them in and showing them data and having them interpret data on their own quality. And that was also a kind of a very important shift. The idea that we could actually have continuous improvement through quality discussions every day, and everybody could be intelligent. You needed everybody to use their brain in what they did. So that was kind of Ishikawa also invented or popularized this cause and effect diagram. This is just an example of one here, but you start off with a source of deviation. Deviation from what? Deviation from the target, whatever the target is. If it's zero defects, for example, then you start asking, well, why are there any defects? And then you proceed through what's called the five. Well, this is a little bit mixing two ideas, but there's another concept called the five whys. And you ask, like, why are there defects? And the answer might go to the first one. Well, production management is has problems. And then you ask, well, a second why, which why does production management have problems? And then you get to an answer like, well, the time control of the production process is out of range. And you say, well, and then you ask a third why. Why is the time control out of range? And you get to, well, somebody, is let's say that somebody is handicapped and or performing lower than average, and therefore the range isn't set right. And then you ask, well, why is the person who's handicapped not accommodated? And so you go down these steps and eventually you get to a resolution. And when you do that across the entire range of causes, you actually achieve a transformational improvement in quality. All right. So this is the Ishikawa diagram. I literally use this in court cases. I use it in my expert witness testimony all the time. When we get into the situation, it's a very simple and compelling. It can be simple and compelling, depending on how you do it. And I know it looks kind of simple when you actually start doing it. What happens, I can tell you from experience, is that the causes and effects begin to blur, and you have to start sorting out, was that a cause or was that an effect? And that's the important, really, that's the challenging part about this that forces you to actually discipline your thinking and get to what is a cause and what is an effect, and how does that all relate to problem resolution and quality perfection. There was another theorist named Taguchi. Taguchi invented the quality loss function, which is basically a way of measuring financial losses to society resulting from poor quality. So quality, and this connects to another idea, which was not by a Japanese person, but it was in the same quality era. And the theory related to the four costs of quality. And quality costs are often measured in four categories. One is called the cost of external failure, which is if I deliver a bad quality product to somebody and it blows up in their operation, there's a cost to them that is external to me. That's an external cost of quality. The second category is internal quality cost, and that's what does it cost me inside my operation, for example, to refabricate, to remake that product correctly. That's cost of internal quality. And then there are cost of appraisals and cost of prevention, which is the important one. So if you prevent the quality defects from ever occurring, you never have to deal with the external costs or the internal costs of. So anyway, so Taguchi invented this thing, this aspect of this measurement of quality defect, and his was called quality loss function and quality robustness. So he was actually trying to, because a lot of people said, well, that's outside of my control. So Taguchi sort of took the measurement of what's outside our control, and he perfected it. So now to get accountability to what is inside people's range of control and what they can do about it. So the main things that this brought up were integrated into Toyota's production system. Toyota really came up with a way of standardizing perfect quality products. And this was based on a lot of principles that were documented and very explicit. There were 14 principles, and here they are. Each one is a philosophy. It's a very interesting way to manage, and it really does change. People, it's hard to understand how philosophy comes in and merges with operations and supply chain management. But this is what Japan primarily brought, I think, to be honest. You have to kind of go to the shop floor and talk philosophy with people. And then they begin to really understand how to manage operations better. Number one is to base your management decisions on long-term philosophy. Well, that is a really hard ask, especially in an American society, which is driven off of quarterly earnings and performance, pay for performance, and weekly wages that are tied to what you did that day and that week. So we still have trouble with it in America and to some degree in Europe, making decisions that are not driven by, I mean, especially as I'll bring in my example of sustainability, where really the challenge is multi-generational decisions, because we can make a decision in this generation that is not sustainable for the next generation. Farmers are better at this than we are, because they have to plant trees, and olive trees, for example, have a gestation period of 75 years. They, not gestation, but a life until, well, that's true, until they bear fruit. So you have to plant the olive tree, and then your next generation and the generation after that harvest the fruit. So, you know, a long-term philosophy is number one. And then a continuous process flow to bring problems to the surface is number two. The idea is to create a process that highlights the problems. And of course, that's the reverse of what most people want to do. Most people don't want to see or understand their own problems, especially at the workplace in front of other people. But the philosophy here is problems are, you should see them every single day, every single minute. And the third is using pull systems to avoid overproduction. We're going to talk about that in a minute. A pull system means you make what has been ordered and not before it has been ordered, which means at every stage of the way through a supply chain, it means that you would never produce anything to put it in inventory. So if you think about that's a huge change in thought. And it's also, it challenges a lot of the mathematics underneath supply chain management and operations management, which is to take advantage of economies of scale and produce in large batches and ship things via large ships. So in order to properly implement a pull system, you need what's called a one-piece flow, which is sort of theoretical, absolute. You should only produce one thing at a time when it's needed. So if you think about that conceptually, it's really a challenge. I mean, how do I produce, you know, one pair of shoes for people? You know, means everything's custom, right? But not custom, it just means you're not supposed to order until you actually have a end customer order, not an order from from a distributor or a agent or something, but an order from a customer, an end customer. And then there's all sorts of other principles like leveling the workload, which is another philosophical change. So if you have 5 things to do, like a student takes 5 classes, so one way to schedule the work for the week is to schedule to study each class one day of the week, right? That means you would study math on Monday, literature on Tuesday, science on Wednesday. But leveling the workload is a totally different paradigm. It means you should work 1/5 of each of them every single day. And people get into these arguments to say, well, why? It doesn't make any difference. But the idea is reliability, producing a completely reliable process. So if you work on math on Wednesday and science on Thursday, but then you get sick on Thursday, that means your next time you're going to study science is going to be the next week. So it means you're going to be far off balance for the next 2 weeks. So the idea of this level loading is to be completely synchronous at all moments. And when you begin to think about this stuff, not to get crazy, but you do go a little crazy, you change your life. You start thinking about the time you set your alarm clock every morning. You start to think about how you eat breakfast, how you fill the dishwasher, you know, and it goes a little crazy because you start thinking about, why do I do it this way and not a different way? I should level load. I should have a continuous process. And there are all sorts of things in here that continues to go on and on and on. And really, another one down here is visual controls. Visual controls to indicate what the status of production is to everybody all the time. They're called signposts, andons, etc. Without knowing the status of operations at which everybody has to have visibility to it all the time. That means your problems are everybody else's business all the time. It's a really big change, and Toyota really invented a lot of these principles, and they are used around the world today. I'm not going to go through all of them, but the other thing they came up with was 13 pillars, which is a little bit different. These are more specific techniques for how to make sure these philosophies are embedded, and they're also similarly brilliant. Take number 2, for example, which you guys might know more about than I do, a lot more about than I do. But in management, this translates to mistake proofing, which is basically making sure that you can't make a mistake. It's designing a process so that nobody can make a mistake. Very simple example on your computer. If you press delete, sometimes you get an error message. Sometimes you get a message that says, "Are you sure you want to delete?" Right? Well, before they had that, I remember I had a lot of accidents, right? I'm old. I remember mistakenly deleting computer files long ago before this error message ever came about, right? This is Pokia. This is basically making sure that people don't accidentally have mistakes. So whenever you have a mistake, the converse of that is whenever you see a mistake happen, there wasn't Pokeoke, right? Why did that mistake happen? No mistakes should happen if you set up the process correctly, right? It should go right every single time. And then, I talked about the andons. Another one is, and Jidoka, equipment designed to stop automatically when problems occur. Okay, there's a problem. Well, everything should stop, right? The whole production line. So just think about a big auto manufacturer or assembly plant, right? It's kind of this huge operation. One thing is out of whack. Let's say that a panel has a little bit of an extra edge, a 1/4 inch extra too much on one panel. Well, one of the pillars is the whole production, the whole assembly plant should shut, right? Should shut down, and everybody should focus on root solving that one problem until it's fixed. And then the whole system should start up again. The idea is simply that you can't kind of bury or minimize problems. Problems are, instead of problems being something that need to be hidden or need to be kind of washed to the side, problems need to be elevated and group problem solved in real time. So lots and lots and lots of changes coming from the Toyota production system that are really worth learning about, and there are all sorts of sort of degrees in this that you can get. This corresponds with just in time, which was also brought to Europe and the United States from the Toyota production system and Japanese management, and we still use these just in time concepts. And today, just in time is in radical reversion, I would say, because although just in time was a huge improvement, because it by operating just in time, it leaves you no buffers. The whole principle, the concept of it underlying is that there are no buffers, right? There's no inventory in between. You do everything just when it's needed, which means you need 100% reliable process. If it's 99% reliable, your just-in-time system is going to fail 1% of the time. And that's not okay. So just in time goes along with 100% quality and all those principles that I just mentioned. And it's really important. The reason why I mentioned just in time is today in question is because with nearshoring and isolationism and the splitting of the hemispheres right now, and what's going on with and even sustainability, that there are a lot of forces right now that are sort of making us rethink whether it's a good idea to ship everything. Well, actually, this might go in the direction of just in time. We might say, well, the American and European companies may actually be able to implement just-in-time more correctly instead of shipping parts in or whatever it is in textiles in from Vietnam, which takes 3 weeks on a boat and 2 weeks in customs. We might do local sourcing and nearshoring and be able to operate a just-in-time operation more here like the Japanese did with the Toyota production system, where the plant and the suppliers were set up adjacent to one another, and there really was the potential to implement true Kanban and just-in-time. So anyway, these are major changes that occurred. Another one is waste. Taiichi Ono popularized this lean principle called the 7 categories of waste. Number one is overproduction. I already mentioned that anytime you produce the inventory or you produce something that isn't immediately consumed by a waiting customer, then that's called overproduction. So that's connected with just in time. The number 2 thing in here is queues, which means any kind of idle time, storage, waiting, anything of queue is really unacceptable. It just is not part of the process. There should be no waiting. I think about this every time I drive down the street and I stop at traffic lights, right? A traffic light is a queue. There are people who spend their lives engineering traffic signals, right? But for me, every time I drive, I think about how inefficient traffic is with stops and starts and waits. This is in the it's waste. It's a waste of time. It's a waste of energy, brake pads. It's a waste of gas to accelerate every time. So the idea is really to design a system that just continuously flows without any deviation. Any transportation is a waste, according to Taiichi Ono. Any transportation. And wait a minute, people say, well, wait a minute, that's not possible, right? Because you gotta move stuff, right? Well, then you think about it harder. You think about it harder, and you say, well, why do I have to move stuff? Well, because your factory is here, and because your suppliers are there, and because your customer is there. Well, why is your factory here? Why are your suppliers there? And you start redesigning it. Maybe I don't have to really move the stuff. Maybe I could. Then you start re-questioning the product itself. Well, I have to move the product between the work in process and the end finished goods. And so, well, why do you have that work in process? Why do you make it that way? Why do you even? And then you start questioning, why am I even? Maybe my tooling mechanism, maybe that whole idea of making it is wrong. Maybe I should just print it with a 3D printer, maybe. And these are all very productive. It sounds at first like they're stupid and unproductive principles that are very constraining. But when you really apply them and you get lean thinking in a team, you get some breakthroughs in thinking that are transforming the business and that allow you to be more competitive. Any motion, for example, is a waste. I mean, I think about the classrooms. When I don't teach this in a classroom, we sometimes have, I just ask, what about this whole teaching experience here is a waste? Well, motion. Well, for example, everybody walks into the classroom. The walking is a waste, right? Why do you have to walk into the classroom, right? And you start redesigning the chairs, and you start redesigning the layout of where the class is, and then maybe re-question of whether they should do it remotely or why are they even coming into campus. And because it's really a productive exercise to think about why motion is a waste. And, it's a philosophy of, all right. So there are a lot of different principles that Taiichi Ono brought. Now, Hirano also developed the 5S methodology, which is another kind of, it's a bit simplistic, but then again, it's not. So these are 5 principles: sort, simplify, shine, standardize, and sustain. And number 1 is sort. So sort things into their respective place. Just to give you an example, when I was working at General Motors in the stamping plant, we took people's desks, and then we put tape on people's desks to designate where should be their stapler, where should be their scissors, where should be the paper, and how much space should there be for each, right? This is a kind of anal compulsive application of sort, but it is absolutely where it goes. The idea is to get you to think, if you haven't thought about whether or not you need a stapler on the desk, how big a stapler it needs to be, where it should be with respect to the scissors and the paper. Maybe should it be on the right or the left? Should it, this is all part of the perfection process involving, yeah. So anyway, sorting is really important. And then the second one is simplify and straighten, which means basically, why is it not linear? Why is it not curved? Why are you doing things in a loop? So simplify is kind of another really important one. And then shine, this one always is worth debating because, cleaning, right? So you might be familiar with like Montessori schools, which kind of teach children a different way. And a lot of it involves letting them or enabling them to clean when they're young. Well, cleaning, I have debates about this with my class all the time. What importance, what does cleaning, how does that help you run a better production operation? It's all sorts of things. It's first of all, there's actually physical dirt and slime and stuff, a banana peel on the floor, you could slip, right? So cleaning is kind of very basic on one level, like for safety. But it's also then, how can you expect to have perfection and zero defects and zero tolerance if there's a little bit of dust on the screen? Then you can't have a perfect 100% reliable process. The dust might interfere with visibility. The visibility would not allow you to see, and then you make a mistake, right? And then there's the aspect too that's more trust, that's more confidence, that's more pride in the process, right? Some people used to wash their cars every day, every week, right? They love their car, right? But well, there's a sort of an aspect to that, to the cleaning involved here, which is that you should be proud of the process. You have to be proud of the process to want to improve it continuously and to have zero defects and zero that, yeah, you can't do that without being proud of it in a way. So shining is important, and every one of these goes deep and deep, and I don't have time to go through them all, but they're really instrumental in a lot of the process improvements that we came about, and it became connected with this whole lean manufacturing movement, which still exists today, and it is pretty much the idea of taking any kind of operation, especially a supply chain, which is hard because it's multiple actors in a relationship, and getting them to all do this together. It's almost like taking a rowing team, everybody on the rowing crew boat has to be turning their oars at the same time. And if they're turning them see, I am not a rower. You can tell I'm using the word turn the oars. What do? You push an oar, you pull an oar, whatever you do with the oar. You have to be doing it at the same time as that person next to you and the person next to him or her, or else you'll conflict and everything will fail. So one of the concepts that happened that became very popular is called Six Sigma. Six Sigma is the idea of reducing the variation in any process to 99.9997% reliable, capable, they call it, which means that you're only going to have a defect, which means an out of tolerance situation compared to whatever tolerance target you set, 3.4 times out of a million, right? Which is a pretty low target for quality defects. In fact, it's very low. So what it involves basically, I'm not going to do this example with you just for time, but if you look at the chart down here, you see what's a 3 sigma curve, which is a kind of, it has a lot of tails on the right and the left, right? These are the parts where you could have, well, it doesn't happen very often, but there's some out of tolerance stuff on the far end of the part in the middle is the mean or the average. So you have a lot of distribution of stuff that sometimes it hits the mark, sometimes it doesn't. It usually does more often than not. The center that's the average. What Six Sigma does is it forces that curve to have a high peak in the middle and very little variation on the right and the left. And between the right and the left, it's 3 sigmas to the right. Sigma is standard deviation. 3 standard deviations to the right and 3 standard deviations to the left. So you basically set your tolerance using what's called statistical process control, which is kind of here. You set your tolerances using this math so that the an upper control limit and a lower control limit of whatever your value is. If you want the coffee cup to be 17 centimeters high, or what, that's too much. So 4.3 centimeters high, and if it's 4.32, that's too high. You have to throw it out and make a new one. Or if it's 3.8, it's too low and you have to throw it out. So you set these control limits depending on the sigma values that you're targeting. And the tighter they get, closer to the center, the more you're getting into Six Sigma. So what you start off with is a process that's very, very sort of loose. I worked a lot in, well, I'm not going to name specific countries because it'll make me sound like politically incorrect. But I've been in a lot of companies and a lot of countries where basically that's the way it is. Sometimes it happens, sometimes it doesn't happen. It depends if it's a holiday, if it's a long weekend. And so we didn't have this, and people are still hungover from the whatever. And, the idea of Six Sigma is you really tighten it up, but there's no variation. And that's a science, a statistical science behind everything we just talked about. Okay, so Japan brought a lot of ideas that are really important to all of American and Western operations and supply chain management. But Japan also suffered a lot of resilience. The next topic that really comes up in this whole field, I think, is the earthquake and tsunami, and then the pandemic, and all this stuff gets us into a new era where you have to consider stuff beyond just a reliable process that's based on a steady state, because we began to have all these horrible upheavals. And then how do you deal with that? Because the steady state science of the whole Toyota production system is based on the assumption that you've got a kind of a normal situation that you're improving. But if there is no normal situation, it doesn't work. So we had this, the whole earthquake situation, and Nissan suffered a lot of shocks to its production facilities actually during that. And the funny thing was, not as funny, but the unusual thing is that Nissan and other automakers actually had plans. They had contingency plans. They had developed like all sorts of they had what was I going to show you here? They had an earthquake response manual, you know? They had reinforced the buildings. They had preparedness assessment and evacuation drills. They had real-time employee information system. Even before the pandemic, they knew where all the employees were in the event of an earthquake. So all this stuff sounds like, well, they were prepared, right? But they really weren't prepared. There were still a lot of damages, and the good thing was they were able to recover in less time than it would have been if they hadn't had those things, those preparedness exercises and those preparedness capabilities. But with this kind of a process, really, these things, there's a better way to prepare for these. So, and that's what I want to talk about. So, and it's not, the Japanese didn't particularly introduce these better ways, but there is a technology or a management process called risk exposure method that comes from a professor at MIT who I know, and I use his textbook, named David Simchi-Levy. The risk exposure method involves computing the time, what's called the time to survive and the time to recover of a failure somewhere buried deep in the production process. So typically with a product that's sold, and even a service, you have components of that, and then you have subcomponents and subcomponents, subcomponents. And what this does is this actually involves computing. If we are short or have a failure or a tsunami, earthquake, something happens, and how much is it? And if we become short of that input, how long do we have to still be able to produce whatever it is up here that we're making? And how much is it going to cost us when we have a failure to recover? So let's say you're making TVs, and the TV has, let's say for simplicity, 10 parts. And then it's composed of one major part, and it has two subparts, and each of the two subparts has 5 subparts. Then you run out of one of the subparts that's sourced from Korea. There's a fire somewhere and you're missing a subpart. Well, if you have a little bit of inventory, you're going to be able to survive for a little while. But then when you run out of the inventory of that subpart, you can't deliver any more TVs. So what you do is you go and look at every single subpart, and you start looking at those that have the longest or the riskiest exposure, which means that they have the shortest time to survive. How long is my operation going to be able to continue producing TVs? If I run short of this part or this component or this subcomponent. And then you rank every one of them relative to every other part at every level. And when you're talking about something like an automobile that has 3,000 or 4,000 parts, it's quite an exercise to try to figure it out for every single part. But what you find is sometimes just like, the story that if there's the parts that are most prone to it doesn't matter how small they are, right? It can be a screw or a little plastic part or whatever, and you could be making an aircraft engine. But if that part is missing, failed or broken, you can't produce any more aircraft engines. You're stuck. So the idea is to go back into the bill of materials and I do this for every single component and subcomponent. And it's better than Nissan's approach of the preparedness for the earthquake, because you actually are able then to take preventive measures for each of those subcomponents and develop a resilient supply chain around it. And this is what now the auto companies are working with some of the consultants on this. This is an example I use in my classroom. Don't give it out to anybody, because this is part of the solution to one of the quizzes. So don't I want the students to know. But anyway, so risk is becoming a more commonplace event. It really is mathematically becoming a more commonplace event. It's not just general, okay, well, it's, everybody says it all the time. It is. And part of the reason why there's a lot more supply chain risk than before is because trade has soared in the last 50 years. And now we import and export, so we're much more interdependent than we ever were. And we have to deal especially with dependence on China. And for most of our products, especially batteries, and some of which were about 98% dependent on China for some products, we all working on it. And we're working on the dependence on Taiwan for chips. These are issues that will take governmental impact. So I wanted to get into, just before ending or before opening up to Q&A, I wanted to talk about the future, because I think Japan has a huge opportunity in robotics and digital supply chains. And this is where I was at a Ministry of Finance event last week, and Japan Ministry of Finance, there's a lot of concern about productivity in Japan and labor force and demographics. But I think Japan has an extraordinary opportunity in electrification and automation and AI. As we move into what's called Industry 4.0, which is basically the idea of having the Internet of Things, or IoT, and connected networks, away from sort of the Industry 3.0, to me is like when you had your TV remote and nobody knew how to work it, right? This is the classic thing. Like for years, I don't know how old everybody is, but for years I had the TV remote. You had three remotes. None of them did what you wanted to do. You couldn't figure out the human machine interface. It was like this went on for years, so like 30 years, I guess. Now we're in industry 4.0, where there should be some kind of a sensor somewhere, detects what you're trying to do and helps you do it before you even realize you need to do it. This is a form of advanced poke-yoke, actually. The same, like just do it for me without informing me, just so that things go smoother. That's industry 4.0. And we're getting there. One of the big changes happening is in order to make that happen, we have electrified and automated devices of all kinds, including electric vehicles that are autonomous and self-guided and self-operating. And my company is working on a lot of this for our clients, and we're looking at advantages versus the current technologies for electrification of all sorts of things that used to run or currently run on oil, gas, and power, from ships to forklifts to robots. And so that gets into this. I would ask you a question now. Which of these is the robot, right? That's my question for you. This is the interactive part. Go ahead. Which of these is a robot? I can't read I can't read the inputs. Let me see if I can. I can't read. Oh, wait, maybe I can.
Some people say all of them.
Yeah.
Everything.
Right. So that's correct. So they are all robots, right? So the ship is going to be propelled and automated, and it's certainly going to be electrified in the near future. There are electric vessels already out there, especially the smaller ones. And once they're electrified, they will become autonomous, meaning they can run by themselves, because the battery is connected with all sorts of electronics, and electronics are connected with controls. And once you have controls and sensors, you don't need a human being driving these things anymore. You can make them into basically these kind of self-guided robots, and the Teslas and examples. All these things, which used to be currently mostly operated by human beings, probably won't be in the future. And so we'll be kind of moving toward autonomous global supply chains, what I call autonomous global supply chains. And I'm writing a new book on this. It should be out in January. And the idea, I don't know if I have it in here, but I'll give you the title later. But Japan, the reason I bring this up to connect it back to Japan has a lot of strength and competitive advantage in process controls, screen technologies, optical sensing, and some battery applications. And I don't know why CATL is on here, but sorry about that. But there's a lot that Japan has to add to this whole field. Companies in robotics are doing very well. Machine and process control. Yokogawa is just a luminary in anything process control related. Sony and Panasonic. I'm working with Toshiba right now on battery technologies for devices that they make. So there's a lot going on, and there will be more need for what I call vehicle to vehicle and vehicle to ground communications and controls that will make all of these things enabled to be self-moving and autonomous. So this brings up some challenges and opportunities, one of which is that Japan in particular is struggling with a little bit of a productivity and a labor force shortage. But the robotics, I think a lot of people recognize right now, are a potential solution to that. So we actually have robotics substituting for people. This is basically the definition of increased productivity per labor hour. And so not only could Japan solve a lot of these robotic problems through its technical competences, it could also solve some of its problems domestically by substituting labor with machines and automation. When we get into the digital aspects of the autonomous global supply chain, there are a lot of aspects to this which are covered in my upcoming book, which I'm writing with two professors from Boston University. and they range from demand planning to payment. There's a really an interesting change going on, and it will involve a complete revamp of the educational system, because right now, and when I say the educational, almost every educational system in the whole world, right now we have all our functions and disciplines and majors, and they're kind of all oriented around traditional way the world works. But once you introduce AI, it's the tip of the iceberg, and the students will not nearly being able to, we're not going to have the same functional disciplines anymore. It's a big change. It's a very big change, and we need to go back to the way middle school and in particular, my book looks a lot at graduate schools, but eventually it's going to work itself back into our whole process. So this does leave a lot of room for potential collaboration for you and for at governmental levels and at every other level. I think it raises a lot of thoughts and a lot of opportunities. I expect there to be a lot of dialogue, a lot of debate, and a lot of initiatives around how we can collaborate to make all these new technologies work for us instead of working against us. That includes artificial intelligence, it includes machine learning, it includes automation and autonomous vehicles and all that. And so here's some two articles. If you want a copy of the presentation, let me or Yumi know, and then you could there's an interesting article on Amazon robots. There are 12 types of them. You can say what types, what they do. There's also an article on artificial intelligence in developing resilient supply chains. Those might be fun if you're interested to read what's going on, and feel free to contact me if you ever have any questions on all this stuff.